My name is Tim Warner, and I want to welcome you to this course called Networking for CompTIA A+ 22901. This course is part of our learning path for the latest and greatest A+ Certified Computer Repair Technician certification. This is the first module in that course, and its title is Network Cables and Connectors. A learning path here at Pluralsight represents a series of courses that map to every single objective of a given certification. Of course, we're concerned with the CompTIA A+ here, so let me quickly walk you through those tables of contents. First, we have a very short introduction course that sets the stage for the certification. The first content domain is called hardware. Very self-explanatory title, I think. Same with this one, come to think of it, networking. Then we have courses on mobile devices and troubleshooting. This networking course consists of 8 modules. Again, you can compare this table of contents to the line items in the networking domain on the CompTIA A+ 22901 exam objectives. You can get those objectives by visiting the CompTIA website at comptia.org. This first module, as I said, is all about media access control, namely network cables and connectors. Then we spend some time on the TCP-IP protocol family. Actually, quite a bit of time indeed. There's a module on basics, another one on ports and protocols. Then we focus on wireless networking, small office, home office networking, internet connection types, network architecture devices, and finally networking tools. After all, the A+ does have us in the job role of the repair technician and not the network support professional. Let's get right to the good stuff. In this module, we're focusing on low-level network cabling. Now, you'll learn before too long the Open Systems Interconnection, or OSI, reference model. Here, we're concerned with the lowest physical layer of that model. I want you to understand the basic coaxial cable types, twisted pair cable, fiberoptic cable types. We're going to focus on current standards. One nice thing that CompTIA has done in this latest iteration of the A+ is that they've gotten rid of a lot of the legacy networking that's good from a historical perspective, but not good in terms of 2015-2016 networking. We'll finish the module understanding how cables work together in a business and how you as a network administrator, if that is part of your job role, can most efficiently route cables. Let's get started. Meanwhile, in the real world, if you've been following this learning path sequentially, then you know that I like to bookend each module with an interlude, so to speak, some questions that you're liable to see, maybe not so much on your certification exam, but certainly in the field as a working A+ computer repair technician. What I do is give you the questions here, and then at the end of the module, we'll revisit and answer each question as a way to validate your new skills. The first question is, how can I tell if the shop that I'm working in uses A or B Ethernet? Now, of course, you might be thinking, Tim, what is A or B Ethernet? So more will be revealed. Let me just say that here. The next question is, and this is a very common question in industry, is we have an Ethernet and it's working, but I have no earthly idea which switch port here in my telco closet corresponds to which user's computer out there in the office. That's not a good situation to be in. In this module, I'm actually going to cover 2 objectives from the networking blueprint on the A+ 22901 certification exam. First, we're going to do 2.1, which says that we need to identify the various types of network cables and connectors. And we'll also cover 2.2, which asks us to compare and contrast the characteristics of connectors and cabling. It just seemed to me that these 2 bullet points were so similar that it made the most sense to combine them seamlessly. Now, a quick level set. I've mentioned several times that we're concerned with the A+ skill set, which historically, job roles for the A+ certified individual are stuff like PC repair technician, help desk technician. You think of computer hardware, you think of screwdrivers, at least I do. Maybe not so much what's covered in the CompTIA Network Plus certification, where that job role is the network technician, somebody who's maybe not concerned with upgrading the RAM in a computer or replacing accessing a hard drive, but instead is tasked with identifying and troubleshooting network connectivity issues. So what I'm saying here is that what we're doing in this part of the A+ learning path is in effect borrowing content from the Network Plus. Network Plus is almost as popular, if not as popular, as the A+ for entry-level IT professionals. So you might want to consider studying for and passing the Network Plus in order to maximize your chances of scoring an excellent first job in the industry. And I wouldn't recommend this if we at Pluralsight didn't have you covered, because we do. In fact, my colleague Ross Bergertis and I have taught the learning path for CompTIA Network Plus N10006. I just wanted to establish this before we got too far into it. Now, let's do some vocabulary, because when we talk about networking and Ethernet, there are certain terms that recur over and over again, and I want to make sure that we understand what they mean right out of the gate. First of all, a wire refers to a single conductor. If you were to take an Ethernet cable and strip the outer jacket away, you'd see 4 pairs of wires. Each pair, each individual wire has its own coding. If you strip that away, ultimately you see the copper wire. This refers to a single conductor. A cable is formally defined as 2 or more bundled conductors. So an Ethernet cable certainly qualifies as a cable. It consists of multiple wires. Cord is sometimes used incorrectly for Ethernet cable. Technically, a cord is a cable that's optimized for extreme environments. For instance, the lamp that's on your desk has a very rigid and, dare I say, armored cord that is really technically a cable because it consists of multiple wires, but its use case is fundamentally different. It's meant to be manhandled, whereas you typically don't touch Ethernet cable very much once it's been terminated and connected. Going further, some other terms. Crosstalk is something that we hear a lot with computer networking. This refers to unwanted signal transfer between communications channels. As we're going to see a little bit later in this module, when you're deploying Ethernet cable, yes, each computer is going to have its own patch cable, but those cables will eventually become aggregated in your wiring closets, and the question comes up, is it possible for signals to bleed from cable to cable? The answer to that is yes, it is possible. Electromagnetic interference, or EMI, is sometimes conflated or combined with the word crosstalk. It's signal bleed, when one signal disturbs another. And the bottom line is you want to minimize crosstalk and interference as much as possible. And as a matter of fact, twisted pair cable, the fact that the wire pairs are twisted, is meant to address that very same issue. Finally, attenuation refers to the gradually increasing loss of signal strength. Hopefully it makes sense that the longer a Ethernet twisted pair cable is, gradually you're going to get a drop-off in signal strength. That's why the Ethernet standard specifies maximum segment lengths for those cables. Fiber optic, because it uses light rather than electricity or electrical pulses, can typically travel much farther distances before suffering attenuation. We'll start our tour of Ethernet cable types by looking at coaxial cable. Now, coaxial cable has been around for a long time. In the history of Ethernet, as a matter of fact, the original Ethernet specification called for using coaxial cable, the so-called 10-base-2 and 10-base-5 standards that fortunately CompTIA took off the A+ objectives. Coaxial cable, I'm sure you see if you have broadband internet at home or if you have digital cable TV. You've seen these. They're not particularly flexible cables. They're almost cords in a way because they're just so industrial strength. But fundamentally, inside the copper cable, you have a copper conductor and then layers of insulation. This could be foil, it could be wire mesh, it could be both. And finally, the outer jacket can still serve as an insulating material. Now, what are we insulating? We're insulating the copper conductor so that it can transmit bits or data streams, and we're also insulating the cable against interference from other sources, electromagnetic interference from other sources in the environment. Now, you do need to know for your A+ exam the copper cable specifications. Specifically, the coaxial cable is called radio guide or radio grade cable, so the standards start with RG. RG58, I'm going to have to backtrack a little bit. I guess CompTIA does want us to know a little bit about Ethernet history. RG58 cable, which you see it right, is thinner and more pliable than the cable that you probably have in your home right now for your broadband internet connection, and it was called called Thin Net Ethernet. It ran at 10 megabits per second, which nowadays gigabit Ethernet, 1,000 megabits per second, is the baseline standard. 10 is incredibly slow. That having been said, when I got into the industry in the late 90s, 10 megabit Ethernet was standard, so it was considered fast. The maximum cable length for RG58 Ethernet cable is 185 meters. The standard is normally given as 10 base 2, where the 10 refers to 10 megabits per second, and the 2 refers to 200 meters, which is the round off of 185. By the way, when you see Ethernet specifications, the base in, say, 10 base 2 refers to baseband Ethernet, where the entire width, so to speak, of the cable is used for a single data transmission. Broadband, which is what you have, again, to keep repeating it, for your cable service, for your IP phones, for your internet, can carry multiple data streams on the same cable, and that should make sense because in that environment you're using the same coaxial cable for your digital TV, for your internet, and perhaps even for your home telephone. Anyway, back to RG58. Here we use the BNC connector, which is a push and twist. It's a very solid connection, as you can see it, right? That's all you really need to know about this. Thin Net Ethernet is a dinosaur. It's legacy. It's been totally supplanted by twisted pair. What is in effect even now in 2015 and 2016 are the RG59 and RG6 standards. These are typically used, they define the cable used for cable television and cable internet, and what you need to know there is that the RG59 and RG6 uses the F connector, which you see up here, and this involves a push and screw mechanism. Sometimes it can be difficult to screw down and tighten the connector, especially if you're in a constrained area like behind a high-def TV and you can't really see what you're doing, you have to go by feel. Another problem with RG59 and RG6 cable is that the inner copper conductor is pretty thin, and it can be easy, I should say, to accidentally bend that pin. You want to not do that wherever possible. Sometimes a signal splitter is the only way to go. That is to say, you might have a case where you're bringing in a coax signal from a wall port and you need to feed multiple high-def TVs or multiple sources. So a common refrain that we saw in the previous course in this learning path on hardware is that I wanted to drill in that it's almost always possible to go from one technology to another by means of a converter. Here it's the same song and dance. A signal splitter is sometimes unavoidable in its use, but if you can avoid using a splitter, do so, because the more you split a signal, the more possibility you have for signal quality degradation. Here's another example of a splitter where, for instance, in your business you might have just one RJ45 Ethernet jack available in a wall outlet, but you absolutely need to send or transmit data between two devices, maybe a user's computer and their IP telephone. You can use something like this to split the signal, but again, you're adding unnecessary complexity, physical layer complexity to your environment. Twisted pair cable is where we want to spend the majority of our time because this is the most common cable type in business data networking. Twisted pair copper cables come in a couple varieties: unshielded twisted pair, which you see here, and shielded twisted pair that actually has extra foil sheathing on each wire pair and potentially around all wire pairs. Shielded twisted pair, or STP, is going to be more expensive than unshielded. You would use shielded if you're running Ethernet cable in environments that have extra high levels of electromagnetic interference. Even fluorescent light tubes can cause EMI, I'll have you know. Now, the twisting in twisted pair actually dates back to the 1800s. The American inventor Alexander Graham Bell patented the twisted pair standard because through his experimentation, he learned that as you pass electricity through a copper conductor, the data may flow in this picture from left to right or right to left horizontally, but the electromagnetic fields that are generated by the conductor operate perpendicularly. And so if you have multiple conductors in a single cable, you'll definitely wind up with EMI interference that can perturb or disturb the data communications. There's actually physics behind it. When you twist conductors together, you actually can cancel out electromagnetic interference, EM fields. It's very interesting. That's all we need to do here as far as your understanding goes. As much as I love electronics and physics, we just don't need to get that deep for the exam. Just know that the twisting is meant to reduce EMI. And with shielded twisted pair, that extra shielding is used to further reduce that crosstalk. A term that you'll see sometimes, not only with twisted pair cabling, but with any cabling, is what's called a pinout. And this refers to the meaning of each wire. In this case, you notice that twisted pair copper cables have 8 conductors total, with each set paired together. So there's a specification that defines which wire pairs are twisted together, and then just as importantly, how you will arrange each of those 8 wires when you punch them down into a connector block. That schematic is referred to as a pinout. Speaking of pinouts, the standard that defines twisted pair Ethernet is called the IATIA 568 standard. There's no IA anymore, it's just TIA, Telecommunications Industry Association. You can visit their website. And their pinout actually has 2 varieties. There's the T568A and B standards. And you'll notice that the difference between those standards is very slight, but do know that they're incompatible. That is to say, if your shop has standardized on 568B, then you'll need to follow that pinout in all of your terminations and not A. Now know that there's no performance or security advantage of one standard over the other. It doesn't work like that at all. In a sense, I don't even really question it. It's sort of like, are you VHS or Betamax? Are you HD DVD or Blu-ray? You'll find, though, in industry, at least if your experience mirrors mine, that 568B is the more commonly used standard. Here's another shot of the pinout for 568A and B. Now, I've told you this several times if you've watched my other training that I'm deeply colorblind, so I'm no good at terminating twisted pair cable. But let's just focus on the B. You'll notice that when you're terminating cable into a connector or into a patch panel, you want to be careful to use the color codes correctly such that you match the specification. That's all you really need to know at this point. More about wiring standards, I guess the other thing you need to know is just the types of cables that you see in industry. A straight-through cable is the most common cable that you find, and you use this to patch, for instance, between a computer and a wall port. And then in the wiring closet, you're going to come out into a patch panel, and then from the patch panel to a switch. These straight cables have the same standard on either end, either 568A or B. A crossover cable, what makes it a crossover cable is the fact that one side of the cable is wired for 568A and the other is 568B. We use crossover cables in peer-to-peer networking. For instance, if you need to do Ethernet data transfer between, say, 2 laptop computers, there was a time that what you do is not use a straight cable but a crossover, because in a straight cable, the send and receive wires on one side are going to match send and receive on the other. So it would be send to send, receive to receive. That doesn't make sense. So a crossover cable just crosses over the send and receive wires such that send from one computer goes to receive on the other and vice versa. Crossover cables are normally yellow as a quick sanity check. This is a special cable, the powder blue rollover cable, where you have 568, say, A on one side and a complete flip of that pinout on the other. That's why it's called a rollover cable. And you use those when you want to directly connect to, say, a router, switch, or a firewall to perform initial configuration on it. Now then, at the end of an Ethernet cable, those 8 wires are punched down into a connector that I sometimes call an ice cube connector, but is formally called a registered jack connector. There's RJ45 and RJ11. At left, we have the RJ11. That's your telephone cable. Simple as that. It's a very small, I'm sure you've used them your whole life. These have 4 conductors normally, but again, normally only 2 are used in practice, one for send, the other for receive. RJ45 is the bigger 8-conductor connector that we use in Ethernet, and we already know that those 8 connectors turn into 4 pairs. Now, just parenthetically, this is more of a Network Plus topic. The fast Ethernet standard, which is 100 megabit Ethernet, uses only 2 of the 4 pairs. So it's possible that if you're terminating your own cable, you could make a mistake in punching down the other 2 pairs and you'd never know there was a problem. But if you decide to go to gigabit Ethernet, in that case, you would see a problem in the cable because gigabit does in fact use all 8 conductors. Finally, notice that the connector end has a boot and a flange. The boot refers to the plastic end that you just slip that on if you're creating your own cable, and the bubble piece is nice because it can help you push down the flange and make it easier to release or plug in those connectors. We need to know the basic standards for twisted pair Ethernet, so this is a table you might want to screenshot. Also check the course notes because I provide you some nice references there. Again, notice that in the standard, the number refers to either 10 megabits per second or 100 megabits or potentially 1,000 or 10,000 megabits per second. And you'll notice in a trend, I'm not going to read every cell here, but just basically look vertically from top to bottom. You'll notice that from the slower standard moving to the latest fast standard, that is from 10 base T down to 10G base T, you need higher grade cable. Cable is graded according to a category system. Category 3 unshielded twisted pair is gone. I hope you never see that. Frankly, I hope you never see Cat 5 either. Cat 5E, Cat 6, 6A, those are the standards in industry in 2015 and 2016. Cat 5 is the bare minimum to do fast Ethernet or 100 megabit Ethernet. Cat 5e is what you want to remember if you have need for gigabit speeds, and you need at least 6A to do 10 gig Ethernet. You see 10 gig Ethernet in data centers, and that's an important exam alert, the fact that you can in fact do 10 gig speeds with twisted cable. You might be asked on your exam, and you may choose incorrectly that you need fiber optics to do 10 gig. That's not true. Now notice the maximum distance. That standard is 100 meters. That's going to mean that from, say, your network interface card in your server or desktop computer all the way through the wall into your wiring closet, you need to keep that distance under 328 feet or 100 meters, or you risk serious signal attenuation. And I've actually seen that. That's not just theory. So speaking of which, you see it left here from the user's computer on his or her desk. The cable first is going to patch into a wall drop and then through the wall, through your run. It could be horizontally through the ceiling, down vertically through the wall, ultimately into a wiring closet where the cable is terminated into a patch bay or patch panel. All of that distance needs to be under 100 meters because it isn't until we patch into the switch that the signal's actually regenerated up to its full signal strength. Now let's look at fiber optic cable. Whereas twisted pair copper Ethernet uses copper and electrical pulses, 0 and 1 voltages, fiber uses light. So therefore, we have much higher speed capability as well as potentially much longer distances. The pros of fiber optic cable are security. Number one, it's a lot more difficult for a malicious person to try to tap into a fiber cable to steal data than it is to tap into copper Ethernet. Another is the capacity for higher speeds and distances, as I said. Some cons of fiber cable is that it's much more expensive than copper, orders of magnitude. And this is interesting because normally in technology we see that as technology marches on, performance goes up and price comes down, but fiber is still a lot more expensive than copper. Another issue is termination. When I say termination, I'm referring to the end of a cable. Whether you're plugging the cable into a switch port or to a patch panel or to a computer's Ethernet jack, that's what I'm talking about. So fiber optic termination refers to how do you put an end connector on a naked piece of copper cable. It's not for the faint of heart, believe me, because you're not just putting copper conductors together like you are when you plug an RJ45 cable into a wall drop. You actually are lining up light tubes that are almost microscopically small, so tightly to prevent light from leaking out of that connection. So termination is a skill unto itself, and also because light doesn't bend as readily, say, as a copper conductor, flexibility is also an issue. You can bend fiber cables to an extent, but you're not going to loop them back and forth in figure eights. You need to know that fiber cables operate in one of two modes, single mode or multi-mode. And what you want to remember is with a single mode fiber cable, you have a single light path through the entire cable. That's going to give you longer distance. So single mode cable is used for wide area networks, potentially on a campus network for connecting buildings. Multi-mode is much less expensive because you have multiple channels or multiple light paths inside the same optical optical fiber, and so therefore you have shorter distances and less outlay. So single mode is for wide area network and potentially metropolitan area connections. Multi-mode is used, say, within a building to uplink a switch from floor 1 to floor 2 to floor 3, let's say, and for connections between your core switches and routers in your data center. Finally, as you see it right, the optical cable has many layers of protection on it, meant to keep the light that's in the inner conductor, the inner fiber, contained. So notice that that piece I'm pointing to right now is not the fiber. Like I said, the fiber itself is essentially microscopic. What you're dealing with the naked eye are all the layers of cladding and insulation that surround the actual conductor. We're going to buzz through these connector types. You need to recognize these by sight for your A+ certification success. SC is a snap-in connector. The ferrule is 2.5 millimeters in size and is a very common connector type for fiber optic termination. The snap-in uses a simple push-pull motion. The straight tip or ST connector is the historical one. It's been around the longest, and here you press and turn in a very similar way to we did with B and C connectors in thin net Ethernet on the twisted pair side of things. The Lucent or LC connector is a very small form factor connector. The ferrule is 1.25 millimeters. Now this particular example shows a duplex configuration where there's actually a separate fiber strand for send and receive. You also can do duplex with SC. This table comes from Wikipedia. I thought it was best to just simply give you a link there instead of retyping it. The bit.ly link, by the way, all bit.ly links that I give you are intended to make it easier for you to go to the link. Now, this link is in the course notes, so you technically don't need to write it down, but if you do, know that bit.ly links are case sensitive. Not the bit.ly piece or the HTTP prefix, but the MGQ do need to be capitalized for the link to work. Anyway, you have the same nomenclature for fiber Ethernet. Notice that the speeds are all gigabit or higher. Base again refers to using the entire communications channel instead of multiple channels. And then you have CX, KX, SX, LX, depending upon whether it's single mode or multi-mode. Rather than get too into the memorization, look for trends, please. For instance, look in the distances that multi-mode fiber, for example, the LX, 1000 base LX, can go 550 meters without regeneration. The single mode variant goes 5 kilometers. And I just think that's stunning. Look at 1000 based LX10. 10 kilometers. That's a single cable going for that length without any signal regeneration. It's amazing. Our final subject is cable runs. Know that traditional cables, we're going to assume unshielded twisted pair or UTP, are coated with polyvinyl chloride that does emit toxic fumes when burning. So to that point, you need to ask yourself if you are tasked with helping to choose UTP cable for an installation, whether you have a plenum or not. A plenum is defined as an enclosed space used for airflow. In a building, your plenum space can be above a drop ceiling and or below a raised floor. And the plenum space specifically many times requires plenum-grade cable, such that in the case of a fire, if that cable does burn, your air movement system, that's also what's happening in the plenum, remember, is not going to send toxic fumes throughout your entire office or potentially across your floor or in your entire building. You'll find that if you move into an office building and they already have Ethernet cable in place, there are probably building codes that require plenum cable, and hopefully you don't have to buy it because, of course, as you would expect, plenum-grade cable is more expensive than standard PVC cable. Final notes on cable termination. I just want to show you some pictures. This is an example of an RJ45 wall outlet where you have an RJ45 connector that behind it has cable that's running through your walls and ceilings. We're going to talk about documentation later in this course, but it's always a good idea to label your outlets both where the user sits, this location, as well as in the local wiring closet where the other end of those cables come through. You see that we're terminating a whole bunch of UTP cable into what's called a 110 block. You're separating each of those 8 conductors and using a special tool to punch them down. Now, on the other side of that mess of wires is this, one or more patch panels, which provide a really easy way to take cables coming in from around your floor, say your users' computers, and patch them into switch ports where they're actually getting signal regeneration and your network policies kick in and the users actually have connectivity in your network. And you can do that patch panel and termination with twisted pair cable and or with fiber cable. It depends on the size of your network and what you've got going on. In this brief demonstration, I want to walk you through network diagrams. It's super important for you to have a visual of what your network looks like. Now, if you're an A+ certified technician working for a company and that's your network, definitely work with your network engineers and have them share documentation. Now, what if there is no documentation? Then you might want to buff up your skills at creating network diagrams. Very briefly, I'm going to walk you through some of the industry standard software. On the Microsoft world, we have Visio. Visio 2013, Visio 2016, may be the latest version depending upon when you're watching this video. But regardless, Microsoft allows you to download the Visio program. This is a desktop application that unfortunately runs only in Windows. And you can download a fully featured trial to see how it works. And we do in our Pluralsight library have Visio training for you. If by contrast you use a OS X system, the standard for that, according to most professionals I talk with, is OmniGraffle. And notice that OmniGraffle runs on Mac and iOS. Personally though, and I am a Mac guy as much as I am Windows, I prefer Diagrammix. This is not a free tool, but then again, neither are Visio or OmniGraffle, but I find it much more intuitive than OmniGraffle, and Diagrammix, like OmniGraffle and like Visio, have network-specific shapes. Finally, if you're maybe a Linux person or you just don't want to shell out for a license, I would recommend the Dia diagram editor. This is a Java desktop app. It's open source and free, and you can do some excellent network diagrams with this tool. It runs, again, universally, Windows, OS X, or Linux, so you can share those drawings on any platform. As I said, I'm a Visio guy, so I'm going to quickly show you a couple representative network diagrams. First, let me adjust the zoom level here. This is an example of a logical network diagram. In a logical network diagram, we're just interested in showing data flows, and we want to show how our network infrastructure looks from a practical standpoint. So you'd share your logical network diagrams with business leaders who may not be technically proficient themselves. The idea is that we should be able to briefly explain this diagram, and even a non-network engineer should say, I get it, I understand what's going on. I've done another one here that's quite a bit bigger. Let me adjust the view level again. It can be tough at this resolution. This shows you a 2-site network. We have a headquarters in Nashville that looks like a core router. The network shapes are generally standardized, by the way. Routers are normally round. Workgroup switches are normally rectangular. We have an internet connection or a wide area network cloud. Firewall is normally represented as a brick wall and so forth. But we have in Nashville, it looks like 3 virtual LANs, one for servers, one for wireless, and another for our users. On our firewall, we have a publicly accessible web server, and we have maybe some internet connection / WAN connection to our Knoxville branch office, which evidently is much smaller because we have only 2 virtual local area networks, one for servers and one for users. Visio is especially cool because you can do ultra-detailed network diagrams. For instance, you may want to diagram your server rack in your data center, and check this out. You can get specific shapes that map to industry products. So here we have a 42U, that's a standard height rack, 19 inches wide. Let's come in even closer. And you can model exactly what that rack looks like. You can download for fun and for free and legally vendors' shapes like these Cisco Catalyst switches, and let me really zoom in. And you can add data to these shapes such that you can even see what's happening on a port-by-port basis on your switches. That's true detailed modeling. And as we work our way down the switch, we have various and sundry Compaq and Dell server equipments, storage arrays, and so forth. And ultimately, it looks like we have a specific American Power Conversion, or APC, battery backup. I hope that that whets your appetite, because that can actually be fun. I mean, diagramming a network isn't particularly fun. It can be very tedious at first, but once you actually have an accurate diagram and you've populated it with data, boy, it can make changes easier to do in the future, let me tell you. Back in the real world, you'll remember that we had those two questions. First, how can you tell if a shop uses the IATF 568A or B? And also, how do we know where cables are terminated? You know how to answer these questions, don't you? To determine A or B, you can ask if there's someone who's been there before you or may know. Another thing is just look at the termination. Go to, for instance, one of your wiring closets, look at the 110 block, and you can see immediately whether it's using the A or B pinout. Cable testers also can easily tell you whether you're doing A or B. With regard to knowing where your cables are and what's connected to what, you can use, again, network testing tools to actually tone out or to determine which switch port or which patch panel port is connected on the other side to a particular jack. And of course, you'll want to document that so you never have to do it again. Your homework, and I like to give you homework assignments for each module because it gives you an opportunity to go beyond the training and start to apply what you've learned. Search YouTube for network and data center virtual tours. Believe it or not, although it potentially can be a security risk, many businesses are proud to show off their network infrastructure, and you can learn a lot by actually seeing live examples of what we've been learning about here. Second, at the least, I'd like you to download the DIA diagrammer, and again, you might want to turn to YouTube for some handy tutorials. Get started on developing network diagrams. Trust me, this is a skill that will help you when you're in industry. For further learning, I'd like to draw your attention to my course here in the Pluralsight Library in the Network Plus skill set, the Standards, Practices, and Theory course, in my module Deploying the Appropriate Wired Connectivity Standard. And boy, is that a long name for a module. Jeez, what was I thinking? You'll find everything we learned here but taken to the next level, because in the Network Plus world, we have to know all this stuff at a greater degree of depth than we do in the A+ one. My colleague Chris Wall has an excellent course covering the Cisco Certified Network Associate CCNA Data Center, but in his Intro to Data Center Networking course, there's a module devoted to media access control where you can get another instructor's take on this material. It's very useful. In summary, what have we learned? Well, I'm going to say that your employer, that is to say whether you're working for a single shop or potentially if you're working for a consultancy, you may have many networks that you work on. That will determine how much networking you get to touch. Officially, you might be a PC repair technician, but I'll tell you, networking comes into PC repair work all the time and every day. As a matter of fact, you'll find that some of your residential mom and pop customers have full-fledged small office, home office networks. So all this Ethernet stuff you're learning will indeed pay dividends. So that's it for this module. In the next module upcoming, we're going to drill into the predominant protocol suite used nowadays called TCP-IP. It's good stuff. Thank you very much for your participation. I look forward to seeing you in the second module. Take care.